Hi, welcome to another lesson with Dr. Hill. Today we're continuing our understanding of voltage for our science. And what we're going to look at today is what happens if we modify our circuit, what happens to the voltage, what happens to the components. So in our previous lesson, what we did was we took a 3-volt power source and we connected it to a resistor and an LED. And what we discovered was that the amount of voltage used up by the resistor and the LED combined added up to the total voltage of the circuit. So somehow the components are sharing the total voltage of the circuit. And this is true for all components that are connected in series. So we asked the question at the end of our last lesson, what happens if we add another LED to the series? So I'm going to have a resistor. I'll have my positive power, I'll have a resistor, then I will have an LED, then I'll have another LED, and then I'll connect back to the negative end of the battery. So let's see how that works. We'll have a look at the circuit diagram and we'll look at the circuit as it's built, and and then we'll test it and see what happens. Okay, so let's have a quick look at the circuit. Here's the circuit. It's basically the same as our previous circuit, except I've just added an extra LED. Now the current flowing through here should be the same because I've still got the same resistance, and we'll talk about current in another lesson. But we've got 3 volts here and 2 LEDs in series. Now what's going to happen? Is the voltage going to be shared out across all 3 components in the circuit? And the answer is yes, but there's a bit of an issue. So let's connect up the circuit. I've built the circuit up here, as you can see. Our positive line, which we haven't connected up yet, is coming into the positive rail of the breadboard. I've got my resistor, and it's connecting up to this column, column 20. And column 20 is connected up to the long leg of this LED. The short leg of the LED, the negative end, is connected up to the long leg of this LED, and that LED goes back to the batteries. Okay, so let's connect it up and see what's happening. And there you go, it's connected and it's not working. So why is that? Well, aren't my batteries working? Well, let's just test that. I'll disconnect that. And I'll take this LED out and I'll connect my resistor directly to that LED. So we're back to our original circuit. Let's just make sure everything's working. And boom, we have a lit LED. So what happened? Okay, so let's set that circuit back up again. I should probably disconnect it before I do that. Let's just do that. And let's get our circuit connected. Which one's the long leg? That's the long leg. And that's the short leg. And we'll put the long leg in. Let's put the short leg in. This is rather tricky to do without... okay, there's our short leg in. Okay. So the question is, can we measure any voltage in this circuit? All right, so let's get the multimeter in, turn it on, and let's see if I can measure any voltage going across the circuit. So let's try the resistor. Ding, ding, nothing. Let's try the LED. This one. I have 1.5 volts going through that LED. And let's try this LED. I have 1.5 volts going through that LED. So there's no voltage being used up by the resistor, and there's 1.5 volts being used up by each LED. Okay, so let's so 0 volts, 1.5 volts, and 1.5 volts. Okay, so what is the problem with our circuit? Let's have a think. So the problem with the circuit in this particular case is that LEDs are not light bulbs. A light bulb will kind of heat up its wire and glow a wee bit if it gets less voltage and less power, less electricity through it. Because it's really all it does is resist the power, and it lights up because it heats up. You make a thinner wire, it resists more, and it heats up and glows. And that's why light bulbs work. They don't burn because they're put in a a gas that doesn't allow them to burn, oxygen-free gas inside the globe. LEDs are different. LEDs require a certain amount of voltage to push the electrons across a gap. It's a diode, and the electrons have to be pushed across a gap. And for that, if they're not pushed across that gap, then we will get no light out of the LED. And in this case, a red LED needs a little bit more voltage than 1.5 volts in order to work. And once it gets that, it'll turn on. So in our last experiment, remember we saw 2.64 volts going through the LED. And the rest of the voltage got used up by the resistor. In this case, almost the entire voltage is sharing itself between the two LEDs, but neither of them is lighting up because we don't have enough voltage. Now, how would we fix that? Well, we would have to go and get a power source that has more than 3 volts. Chances are we might need 5 volts, and then we'll get 2.5 volts through each LED, and we'll light them both up. Okay, so what we're seeing here again is that even with 3 components in the circuit, the voltage is being shared between the components. Let's go back and have a look at the board. That very little voltage is being used by used up by the resistor, and the 2 LEDs are sharing an equal amount of voltage. So they're the same type of component. The red LED, they both have exactly the same components in them, and so they share the voltage equally. Again, we added up 1.5 volts, 1.5 volts is 3.0 volts, which is the voltage that we're putting in. It's being shared, but nothing's happening in the circuit, and I'm going to disconnect that because we're running that around the battery. I'm going to disconnect that. The voltage is there, but it's not lighting the LEDs because LEDs need a certain minimum voltage to light up. And at the moment, we don't have an extra voltage, and we could possibly supply one with another power pack, but that's something we would have to think about in another lesson. So what does this demonstrate? This demonstrates that, again, with a third component, we're sharing the voltage differently, but we're still sharing the total amount of voltage that's being put in by the batteries. So the total voltage of the circuit remains at 3 volts, and that 3 volts is shared out amongst the components in a series. Now, in our next lesson, we're going to look at what happens if we connect the 2 LEDs to the battery slightly differently. And that's an important concept, and we'll talk about it in our next lesson. So I hope you enjoyed that one, and we'll move on with our discussion of voltage and circuits in our next lesson.